Good afternoon. Today I'll be presenting the results from a GLFC-funded study that my research team did to measure depth and temperature occupancy of lean, redfin, and Siscowet lake char using PSATs or pop-up satellite archival tags in Lake Superior. For those of you that aren't aware, Lake Superior is home to 4 ecotypes of lake char, including the Siscowet, lean, redfin, and the humper form. And these are differentiated by their body shape, fin size, head size and shape, eye size, and they also differ in lipid content, with redfins having the lowest levels, while Siscowets have very high levels of body fat. Leans and humpers generally have low levels of lipid in between the two other forms. These fishes also differ in their depth distribution in Lake Superior, with leans being the shallowest forms and Siscowets being the deepest form. Humpers are intermediate in between the other two leans and Siscowets, and they're generally associated with offshore seamounts or island areas. Little is known about redfins, but they are presumed to be intermediate in depth between leans and Siscowets. In our study, we wanted to provide a detailed view of depth distribution and temperature distribution of lake char using new technology. So the technology we employed in this study was the use of the PSAT, or pop-up satellite archival tag. And the way these tags work is we deploy them on the fish and they conduct measurements and archive them. Then on the mission end date, the tags pop off and float to the surface and transmit the data to the satellites. However, in our study, we actually went out and retrieved these tags to increase the amount of data we collect, because a lot of these tags do get lost and aren't recovered. So the tags we used measured temperature, pressure, which is another measure for depth, light level. It also measures geomagnetic field strength, which gives us an idea of location. However, given the large mineral deposits in Lake Superior, which has caused major magnetic anomalies, we weren't able to locate the fish using these tags. The tags also have a battery to supplement data acquisition, and a photocell which actually supplements the power for data transmission once it surfaces. And it relies on an explosive release to release from the fish. Given the size of these tags, we were only able to employ these on Siscowets, leans, and redfins, because the humper ecotype is actually a very small form and weren't suitable for these tags. Here are a few pictures of the PSAT being deployed on the fish leaving the ship. In our study, we had 4 missions where we deployed PSATs ranging from 3 months to 13 months. We had 1 mission that was conducted in southern Lake Superior in the Marquette area with an 8-month deployment where tags overwintered. Then we had 2 summer deployments at Isle Royal, 3 and 4 month deployments. And our final mission, we had a 13-month mission that was at Isle Royal. In total, we had 69 tags deployed in Lake Superior, with 39 of those being recovered. We had 9 that went missing in action. We had 26 that malfunctioned, whether they were recovered or we never heard from them. Overall, we had 34 usable tags in the study. Here's a chart of Lake Superior with where the tags were deployed and recovered at both Isle Royal and southern Lake Superior near Marquette. Most tags deployed at Isle Royal were actually recovered around Isle Royal and popped off near Isle Royal, with few exceptions. The tags we deployed near Marquette and southern Lake Superior, many of those tags actually popped off away from Marquette. Here's a zoom in of Isle Royal just to give you a perspective on where we tagged the fish and where the tags popped off and were recovered. And just zooming in a little more, here's the eastern part of Isle Royal, just to give you a more detailed view of the different tags and the movement patterns there. So this is what the data look like when we download them from the PSATs. In this figure, these are depth profiles that are represented for each of the ecotypes that we deployed PSATs on. The top figure is for the redfin, the center is for Siscowet, and the bottom is for lean. And the y-axis represents depth in meters. The green rectangle represents a depth of 80 meters, which is thought to be the typical depth distribution of lean lake char. So you can see that redfins here at the top and leans on the bottom mostly inhabit waters less than 80 meters. In fact, leans spend much of their time less than 50 meters. In the center plot, you can see that Siscowets actually spend much of their time in deep water, deeper than 80 meters. And in this example, this fish actually inhabits depths down to 250 meters and deeper. And we found Siscowets out to 400 meters in Lake Superior. Using the individual depth profiles from all of the fish we tagged, we developed this figure which represents the bathymetric occupancy, or the annualized monthly depth distribution of Lake Charr. The top panel is the occupancy for Siscowets, and the center is for leans, and the bottom is for redfins. This dashed line at 80 meters, a reference depth, which is the depth leans generally don't exceed. We didn't have enough tag recoveries to plot this for most months for redfins, and only had data for the summer months. We also did not have enough data for the month of October for leans. As this figure illustrates, Siscowets are distributed mostly in deep water and undergo extensive movements to shallow depths, especially during the summer months. We see Siscowets move from depths of over 300 meters all the way to the surface. And the range of depths occupied by Siscowets was really a surprise, given that it's considered a deep water fish. And leans definitely are a shallow ecotype. In fact, we measured depth distributions generally less than 50 meters. And the little information we have for redfins indicates they're similar to leans, although they actually don't venture up to the surface as leans and Siscowets do. In addition to depth, the PSATs we deployed measured temperature for each of the fish that we tagged. And this figure represents a typical temperature profile for each of the Lake Charr ecotypes that we did tag. The top representing the redfin, the middle Siscowet, and the bottom lean. And the yellow rectangle represents the temperature between 5 and 10 degrees Celsius, just as a point of reference among the ecotypes. And this dashed line at 4 degrees Celsius represents the temperature at the bottom of the deeper part of the Great Lakes. And as you can see from this example, which was PSATs from, that did measurements during the summer months, both redfins and Siscowets tend to stay in colder waters, less than 10 degrees Celsius, whereas leans do make excursions into warmer waters. Similar to the depth data, the individual temperature profiles from all of the Lake Charr that we tagged with PSATs were put together to develop the thermal occupancy, or the annualized monthly temperature distribution of Lake Charr ecotypes. And the top panel here represents the thermal occupancy for Siscowet, the center panel is for leans, and the bottom is for redfins. And this dashed line again represents the temperature at the bottom of the deeper portions of the Great Lakes, 4 degrees Celsius. And from these plots, you can see that Siscowets truly are a cold water fish. They rarely spend much time in really warm waters above 10 degrees Celsius. And among all these Lake Charr ecotypes, leans are the ones that inhabit probably the warmest waters of all three. So these definitely are cold water fishes. And what's really fascinating from the PSAT data that we found was the temperatures during the winter months. So on this left side here, you can see that a lot of the temperatures are near zero for both leans and Siscowets, and we didn't have any data for the redfins. So water is most dense at 4 degrees Celsius. That's why that's the temperature at the bottom of deeper parts of freshwater systems. So this would indicate that both leans and Siscowets make excursions into really cold temperatures, probably under the ice. As you can see, these lantern plots illustrating temperatures around zero. In the last half of my talk, I'll be discussing the fascinating vertical movement patterns we measured in Siscowet Lake Charr from the PSATs. From the data, we measured 4 distinct vertical movement patterns, here shown in the yellow rectangles on this depth profile for Siscowet. And I'll talk about each of these vertical movement patterns in the subsequent slides. The first vertical movement pattern that we measured in Siscowets that I'll talk about is what we describe as spawning behavior, here shown in yellow. Some of the Siscowets that we tagged at Isle Royale were part of a spring spawning population that we think spawns around 100 meters on the north side of Isle Royale and during May and June. So this depth profile, I think, represents the spawning behavior measured on some animals that are spawning during that time. And this is just a zoom in to those data, and the darker bands represent nighttime depth distributions, and the lighter gray represents daytime depth distribution. And you can see there's very little change in depth of about 25 meters during this time period. So we would call this spawning behavior. Another interesting distribution pattern we saw in Siscowets was that they spent long durations during the summer months near the surface in really shallow water, shown here in the yellow square. So there's a zoom in here where you can see that their depth distribution at the surface, and you can see they're near the surface during day and night time, and we think this is to feed on surface items that cluster. So this corresponds well with diet data where we see terrestrial insects and bird remains in the stomachs of Siscowets that we've sampled from the summer months. So they are probably at the surface feeding on particles that cluster. The least surprising depth pattern we see in Siscowets is that they spend part of their time in the year on the bottom. Here's an example of a Siscowet that spent a pretty long duration at about 250 meters on the bottom of the lake. The last and most fascinating depth distribution pattern in Siscowets that we observed in the data was these extreme vertical movements. And in this case, for this fish, we see this in the yellow rectangle here of movements of 100 to 250 meters during the summer months. And the frequency varies between and within fish, and the duration and time varies greatly. So a zoom in on this surface movement pattern here, we see they're at the surface during both day and nighttime, and then they go deep, and then they come back up during the day and at night. So I guess the best way that we think to describe this vertical movement pattern is opportunistic vertical movements, which relates to their opportunistic feeding pattern. So to conclude, the goal of our study was to quantify the bathymetric and thermal habitat of Lake Charr ecotypes in Lake Superior. And using the PSATs, we were able to measure both bathymetric and thermal occupancy. So for bathymetric occupancy, or the depths that the animal inhabits mostly throughout the year, for leans it was less than 50 meters. For redfins, with the data that we were able to gather from the limited tag recoveries we had, it was generally less than 80 meters. And for Siscowets, it was greater than 80 meters. And the range of depths that we observed from the tags for leans was from the surface 0 to 128 meters. For redfins, it was a bit deeper. We found them down to about 150 meters. And for Siscowets, the deepest we measured was 360 meters. In terms of thermal occupancy, leans generally inhabit temperatures less than 9 degrees Celsius. For the data that we had for redfins, it's less than 6 degrees Celsius. And for Siscowets, the coldest of all these cold water Lake Charr, it was less than 5 degrees Celsius. And the range of temperatures was greatest for leans. They occupied temperatures from 0 degrees, probably under the ice, to 16 degrees Celsius. For redfins, it was similar. It was 3 to 15 degrees Celsius. And for Siscowets, the warmest temperatures that they were found in was 13 degrees Celsius. But again, most of the time they stay in very cold water. Finally, some of the most fascinating findings in this study were from the Siscowets that we tagged with PSATs. We found that Siscowets inhabit a variety of depths during the year, but generally stay in deep water, generally between 150 to 300 meters from the data we had in this study. But we know they go into deeper waters, but also conduct vertical movements into shallower areas. They can be found at the surface for long periods of time, even during high light intensity at certain times of the year. And the timing of this may be limited by the thermocline. If you recall, these animals like to stay in really cold water, so where the thermocline is placed in the water column may influence when they go to the surface. The Siscowets also exhibited extensive vertical movements over large depth ranges that occur at all times of the year. We see this often during the summer, but also sometimes during the winter where we see them go into really cold temperatures. Lastly, the vertical movements to the surface appear to occur at various times of the day and for various lengths, and we classify this as opportunistic vertical movements. And with that, I'd be glad to answer any questions.